So lately I've noticed some confusion about cell format and other cell implementations in TornadoFX. So this video is about clearing up some misconceptions and also giving you some hints on how to optimize your custom cell implementations. So what you see here is a simple people catalog, and the whole application is basically this view with the addition of getting some people with links to images, and I'm getting it from this randomuser.me API. And I'm fetching 200 people, and every time I run the application, I'm going to get back a different result. So I'm not going to talk so much about the details of the models and the REST API. So we will just be content with that. This function will fill our list view, and we can start the discussion from there. So the application is pretty simple. It contains a list view, and the list view has a custom cell implementation. And this custom cell is implemented using the CellFormat function. What we do here right now is whenever we get a callback, we have a person, and we assign a VBox with an image view and a label to the graphic node of the cell. Now this is all nice. It works as expected. There are no apparent performance issues with this, but let's talk about what really happens here. So to visualize what happens in here, let's have a look at the JavaFX equivalent for a second. So if you look at this example, it's actually for a table view, but even though it's still exactly the same, we can use the CellFormat function the same way for a table view and list view. So let me go back. Here we create a column, and down here we set a cell factory, and cell factory is just a callback that has the responsibility for creating table cells. And we create a custom table cell and override the update item callback. And this update item callback will be called whenever the cell needs to update its contents. So we have a lot of housekeeping to do here. We need to call super. We need to clear out both the text and the graphic. And then if we're not empty and we actually have a value, we can do something to either the text or the graphic inside the cell. So in this example, we actually just override the text and set a style depending on the age of the customer. So this is the custom cell right here. The principle is the same. With CellFormat, what you get is all of this, so that you just need to do the things in here. Everything around here is already done for you. So that's exactly what's going on right here. So if we're supposed to show a person, then we create a VBox with an image view and a label. And as you saw, it works, and it has no performance issues that we can see right now. But what happens here is that even though we just have a few cells in this application, because the list view will only create enough cells that we need to display at once. So right now we have 3, 4, 5 cells maybe. That's all we probably have, and they are reused all the time to show different people. And every time that happens, we create a new VBox, a new image view, and a new label, and even we have to reload the image every time also. That might be good, but it might also be bad depending on the source where you get the images from. So let's talk about alternatives to this. So cell formats can just be swapped out with cell cache, but then we don't need to assign to the graphic node. We just need to return the graphic node, because the cell cache only works with a graphic node. So what happens here is that for every person in the list, we will get one node hierarchy. So isn't that worse? Well, yes, it will certainly use a lot more memory. What it will do for us, though, is to make sure that we only download the images once. So if we were to rerun the application now, of course, while we scroll, we need to load the images. But if we scroll back up, the images are already there. So as we scroll up, the correct node hierarchy with the VBox and the image view and the label is just fetched for us and set as the graphic property of the cell. So for this use case, the cell cache is actually perfect. But if we had like thousands and thousands of people in this list, the cell cache would fall through. It wouldn't be a good solution for us anymore. Even though the performance would be great, the memory usage would be brutal. So we need something else. So let's go back to the cell format. The problem right now is that we recreate the VBox, image view, and label all the time, even for an existing cell, right? So what can we do differently? Well, of course, we could use the new cache function. And what that does is simply run once and create this node hierarchy once per cell. And that sounds great, since we only have like maybe 5 cells. We would only create 5 sets of this node hierarchy. And at first that sounds pretty nice, but if we were to rerun this application now, we will see that we introduced a bug. Let's scroll down and then scroll up again, and you can see most of these people look the same. Weird. Well, actually, it turns out it's not that weird, because as we agreed, this cache function will make sure that what's inside it is only evaluated once, right? So after we created our maybe 5 cells, the person that was first used to create each cell will remain inside here. So now we need to find a way to bind and update the actual contents. We do want to only create this hierarchy once, but we need the actual contents inside it to update. And to do that, we can leverage the item property, which is available in a custom cell. So each cell implementation will always have an item property, and that's also available to us inside of CellFormat. So item property, you can see, is an observable property of person. So this will change as the cell is supposed to show different people. The problem is that we can't simply just extract a value from it. We need to create a binding pointing to an observable property, the picture property, inside of the person. So both the person can change, and of course the picture inside it will change as well. So what we can do is to use the select function, and the select function will create a nested observable for us. So if we do select, we can call person.pictureProperty, and we now have an observable value pointing to the current person and the current picture inside of that current person for us. And we would need to do the same for the label. So here we will use the name property. You might not have seen this syntax before, and it's actually the same as passing in a lambda, but we're using a function reference instead. But this would be another way of doing it. And while we're on that subject, you might not have seen this either, but it's the same. This is a function reference. If you like lambdas, you can do like this instead. Probably that's what you're used to. But I find this cleaner when I'm not passing arguments. I like the function references. So up here now, we don't need the person parameter anymore, because we only create bindings, right? So now we should have gotten rid of the bug, and let's just check that out. Yep, it seems to be working great. So what happens now is that for each cell, we only recreate the VBox, image view, and label once. So we have maybe 5 of them now, and but we still change the image and the label inside as the cell is used to display different people. This has the advantage or disadvantage, depending on how you look at it, that the image inside the image view will be reloaded for each cell and then thrown again. Again, depending on your actual use case, this might be what you need, or it might be bad for performance, right? So I think mostly this is a great trade-off, and I think it might even be more a more common use case that you don't have images, but you have like a form or some kind of large node graph, but it doesn't go out and fetch external resources. And when you don't do that, then this construct with the cache is probably the best solution for you. The cache function by default doesn't need a cache ID. It will just cache one thing per node. And for this example, that's exactly what we need. We just need, for each cell, we need to create one set of nodes and return those and assign them to the graphic node for each, the graphic property for each cell update call. Now, it's also possible to pass in any kind of object as an ID here, the key for the cache. You can see that by default it is this string. It can be any kind of value, really. For a cell implementation, I can't see a usage for it, and I'm not even sure about when you would need to cache different sets of hierarchies inside of any node, but the functionality is there at least. So hopefully this was an overview of the different kinds of cell format and cell cache functionality we have both for ListView and TableView. There are other ways of dealing with this, of course. You can still do the JavaFX way of creating cell factory, custom cell, and overriding update item if you need to or want to. But we also have this cell fragment function, which allows you to point to some fragment, which will be actually the same as what goes on inside of cache here, right? But you can put it in an external file, and you know, if the logic is large, that might be a much cleaner solution. But in principle, it does the same as caching the graphic property, right? So that was it. Thanks you for watching, and this cache functionality will be available in TornadoFX 1.7.5. Bye.